7.3, summing matrices and powers. Our learning intention, what are summing matrices? What are powers of matrices? Our success criteria, I can understand how to identify the summed matrices and solve the matrices with powers. Summing matrices. Rows and column matrices that consist entirely of ones are called summing matrices because when they are multiplied with other matrices, they sum elements. Okay, that makes sense. Not really, actually. So what is a summing matrix? This guy here is a row. As you can see, it's a row because it's only got one row, so it's a row matrix. Row summing matrix. And this guy here is a column summing matrix. So, as you can see, it's got one column, a few rows, but one column. And from 7.1, we learnt that one row and a lot of columns means it's a row matrix. One column and a lot of rows means that it's a column matrix. I think I got that right, didn't I? Yep. One row is a row matrix, one column is a column matrix. So how does this work with a standard matrix? Now, in the previous video, 7.3 matrix multiplication, we learned how to multiply matrices. How you'd have to do multiplication of one row against one column, then the next row, the next column, the next row, the next column. And it's pretty long-winded. But with summing matrices, you don't actually have to multiply anything, even though you've got two matrices that need to be multiplied. The cool and easy thing about a summing matrix is that all you do is you sum. So if you have a row matrix like we do in this first example, the columns are summed. So 10 plus 3, just jotting that down, gives me 13. My 13 goes in the first column. Because I've started with a row matrix, I'm going to end with a row matrix. In the second example, because I started with a column matrix as my summing matrix, I'm going to end up with a column matrix as my resultant. So let's have another look at the second column. 2 plus 7. 2 plus 7 I know is 9, and I've got 9 as my second element because it's corresponding with the second column. And then the third one, blue. 1 plus 5 is 6. So if you follow the highlighter, the orange, 10 plus 3 is 13, 2 plus 7 in the green is 9, and 1 plus 5 in the blue is 6. And all I've done is, as per the little box on the side, sum the columns. Now, if I've got a column matrix, I have to sum the rows. So what I'm going to do is I'm going to go back to my highlighter, go back to orange again, excuse me, and I'm going to add my rows. So 2 plus 4 plus 3, I did check with my 6-year-old, he told me it was 9. And as you can see, 2 plus 4 plus 3 equals 9, and that corresponds with the very first element there. Change colour, we'll try and keep it matching like the other one. 5 plus 1 is 6, plus 9 equals 15. And blue. 6 plus 20 plus 1 gives us 27. So all I've done is sum the rows because I have a column summing matrix. So a bit of an explanation. To sum the columns of a matrix, pre-multiply it by a suitable row matrix consisting of ones. Now, what does pre-multiply mean? Pre-multiply means before. So if you want to add the columns, you have to use a row matrix, and you have to put the row matrix at the start. And again, you end up with a row matrix. And it has to go before the standard matrix. So to sum the rows of a matrix post-multiply it by a suitable column matrix consisting of ones. So if you need to post-multiply, post means after. So this means putting the summing matrix after the standard matrix when multiplying. So as you can see, we've got our column matrix there, and it's going after the standard matrix. And because I've got a column summing matrix, I'm going to end up with a column product matrix at the end of it. So pre-multiply means before, post-multiply means after. So think about football or any sports really. Pre-game entertainment is always that entertainment before the game, and the post-game celebrations are after the win or, unfortunately, the loss. So I've got an example here. I've got matrices C equaling 1, 1, 1, D equaling 1, 1, X equaling 3, 2, 4, 6, 5, 10, and Y equaling 18, 2, 12, and 5. Now, I've got parts A and B where I need to calculate the multiplication of two matrices. The first one is C and X. So, as you can see, let's just identify our matrices first. I don't really like red, but I've got to use it as a bit of a different colour difference. So this with all ones is a row summing matrix. And this one here, D, is our column summing matrix. And as you can see, X and Y are just normal matrices. So part A says calculate CX and comment on what has been summed. So back to blue so I can write everything out. So CX is equal to, now C coming first is a row matrix, 1, 1, 1. And my X matrix is 3, 2, 4, 5, 4, 6, 5, 10. Because I have a row matrix at the front, I'm going to end up with a row matrix at the end. Let's add these numbers up. And because I've got a row matrix, I need to then add my columns. So because I've got a row, I add my columns. So 3 plus 4 plus 5 equals 12. So 12 goes in there as my first element. My second element would be 2 plus 6 plus 10 gives me 18. Now, even though our first matrix, our row matrix, started off as a 1 by 3, I'm going to change colours again, back to red, 1 by 3, we had a 3 by 2. Now, remembering from matrix multiplication, our n values need to match, that's these two here, and our resulting matrix is the two sort of outside numbers. So we end up with a 1 by 2 matrix. Now, C is the summing row matrix, which goes first. So add the columns in X to get the product matrix CX. So what's been summed here? What's been summed here are columns in X. So 3, 4, 5 have been summed, and 2, 6, and 10. And our second question, calculate YD and comment on what has been summed. Back to blue. So notice that Y comes first. So we've got YD is equal to 18, 2, 12, and 5. Close that bracket. And 1, 1. Now I know I've got a 2 by 2 matrix here, and I've got a 2 by 1 matrix here. So I know that I'm going to end up with a 2 by 1 matrix at the end. So I'll pop my boxes there. Now, because I've got a column summing matrix, remembering that, I'm going to add my rows. 18 plus 2 gives me 20. 12 plus 5 gives me 17. So D is a summing column matrix, which goes second. So add the rows of Y to get the product matrix YD. So in response to the second part, comment on what has been summed. The rows in Y have been summed. Now, if you're looking at your textbook and you're going, but you know the textbook says C and D, it's not. It's actually X and Y. It's an error. Not my fault. All right, so, oops, too far. On to power of matrices. Powers of matrices are pretty straightforward. So just as 5 squared means 5 times 5, if we have a matrix named A, then A squared means A times A. Now, only square matrices, let's just highlight that, underline that word there. Only square matrices can be raised to a power, because otherwise the number of columns in the first matrix will be different from the number of rows in the second matrix. If you're unsure, go back and see the matrix multiplication slides or the matrix video. So remembering a square matrix is 2 by 2 or 3 by 3 or 4 by 4 or 17 times 17 if you really want to. We don't work with matrices that big. We really don't even work with matrices much bigger than about a 4 by 4, worst case. So any power of a matrix will always have the same order as the original matrix. So if you start off with A being 1, 2, 3, 4, so we're talking a 2 by 2 matrix. If you had A squared, it would still be 2 by 2. If you had A to the 7, it would still be 2 by 2. The order or the size of that matrix does not change. So use the same methods and steps as matrix multiplication to get the resulting matrix, or use the CAS to save time. Definitely a recommendation. So on to our last slide. If x equals 5, 11, 12, 7, 3, 1, negative 4, 2 and 6, find x to the 4. Now, I wrote out how you would be doing it by hand. You would have matrix number 1, then you times it by matrix number 2, then you times it by matrix number 3, then you times it by matrix number 4. Now, if you flick through my slides and seen the animations, I wrote not a chance, and I'm standing by that. It is too long-winded. Even a 2 by 2 is probably about as far as I go when I'm talking matrix multiplication. Anything more than that, it's just a headache. So, first step, sorry that it's not aligned properly, create a 3 by 3 matrix and enter the elements of x. Now, remembering on your CAS, these are just CAS instructions. On your CAS, it's that little box that has, I think it looks a bit like this. Yeah, that's that button. It's somewhere near the book. So the book button looks, don't criticise my drawing skills. That's your book. It's right now, it's on the other side of the number 9. So enter your matrix. So if we put in our matrix down here, then we press the little hat button. That hat button is along that left-hand side. Then press number 4 and enter. This raises the matrix power to the power of 4. And I still end up with it. So I've started off with a 3 by 3 matrix. And I've still ended up with 3 rows, 3 columns. So just reinstating what I did on the previous page, the order of x to the 4 remains the same as the original x as a 3 by 3 matrix. If the power was to change to 50, so x to the 50, x to the 50 would still be a 3 by 3 matrix. So I will see you guys for 7.4, inverse matrices.